Hello students, this is Shakil and today we are going to discuss Work, Power and Energy video lecture 3 as part of IGCSE Physics 0625 syllabus. We're done with the first two lectures in which we studied about energy resources and efficiency and power stations. You can look upon those videos in the channel. Well, this is video lecture 3 and this is about work and power. So we'll be looking upon work, and especially we'll be looking upon the concept that whatever work you do is actually equivalent to energy transferred or energy transformation. And we have to use two equations: work equals force into distance and work equal change in energy. For the power, we have to do power related to work done and time, and then we have to look for energy changes in terms of the power. So, well, about work, it's a quite simple thing. Let's say that there is a box placed over here, and what you're going to do is you're going to push it. So when you're going to push it, of course, you're going to apply some force, and this push will move the object to a distance. Let's say it covered this distance d over there. Okay, so you are looking upon when you push the box with a force F to a distance d, actually you have done some work, and that work is actually equivalent to product of force and distance moved along the line of action of force. So that's how we define it. So work equals force into distance moved. In symbols, work equals F into d, where F is the force applied and d is the distance moved along direction of the force. The SI unit of work is joule or joule, and it is actually a scalar quantity. And 1 joule equal 1 Newton into meter. Like the unit of work is joule, unit of force is Newton, and unit of distance is meter. So 1 joule equals 1 Newton into meter. That's how you define it as well. 1 joule is the work done when 1 Newton of force moves the object 1 meter in its direction. Well, there are two types of movement when you do some work on the object. One is the horizontal and one is the vertical. So for horizontal motion, if you're moving an object horizontally, you have to find the work done. So you have to use F, which is the force applied into the distance moved. For vertical motion at constant speed, like if you're lifting something up at constant speed, if you have to find the work done to lift that object, that will be equivalent to again force into distance. But this time, the force is equal to weight of the object. Remember, whenever you lift something up, the minimum force that you have to apply should be equal to weight of the object. And d is the distance, which is actually height gained or height. So let's do an example. A box of mass 10 kg is moved vertically up at constant speed of 2 meters per second for 5 seconds. Like you're moving a box up at speed of 2 meters per second and you're moving it for 5 seconds. Its mass is 10 kg. How much work is done on it? Well, work done is force into distance. So actually, you will be looking upon two things over here. First is how much is the work, how much is the force, and secondly, how much is the distance moved. So for force, we'll be keeping it equivalent to the weight of the object, which is like mass is 10 and g is 10, so 100 Newton force is being applied. And for the distance, as it is moving with constant speed, so speed is distance over time, and from here distance is speed into time. So speed is 2 meters per second, time is 5 seconds, so it is 10 meters. So it means that you're applying 100 Newton force and the distance is 10 meters, so the total work that you have to do is 1000 joules. Well, work done is equivalent to useful energy. Like the work that you do on some object will be used to move that object or will be used to move the object vertically upwards. So work done to move the object is equivalent to change in kinetic energy of the object. This is the movement case, that if you do some work on the object and that object gains some speed, it means that the kinetic energy is gained because of your work. So work done in this case will be equivalent to 1 by 2 mv square. So a force moves an object of mass 10 kg to a speed of 10 meter per second, right? Let's say this is an object of mass 10 kg, it was at rest, and you applied some force and you moved it to a top speed of 10 meter per second. So how much work is done? Find the work done on the object to move it at this speed. So we say, okay, this work done is equivalent to change in kinetic energy because of your work, object is moving. So kinetic energy is half mv square. So mass is 10 and speed is also 10. So it means that you have done 500 of work to move this object. The second one is work done to raise the object is equivalent to change in its GPE. Like this is related to vertical motion. When you move object vertically upward, it gains GPE, and that GPE is actually equivalent to work done. So work done is mgh. Okay, so now let's look at an example. An object of mass 10 kg is moved vertically up to a height of 5 meter. Find the work done to move the object. So, okay, work done is changing GP actually. Mass is 10, G is 10, and height is 5. So it means that if the mass was initially on ground and you moved it up to a height of 5 meters, so you have done a work of 500 joules to raise that object upward, and at the end that work done will be stored in the form of GPE, which is 500 joule. Okay, moving forward to power now. Power is rate of work done. So power is equal to work done over time, or power is rate of energy conversion. Power is energy over time. Its SI unit is watt. So watt equals joule per second, as work is joule or energy is joule and time is second. Time is second. That's why we say watt equals joule per second. So when you define it, 1 watt is the power when 1 joule of work is done in 1 second. And power is a scalar quantity, so no need to bother about its direction. About the factors, the things that can affect value of power, of course, the first thing is work or energy if you keep time constant. Like if you do more work or more energy is converted in a time, the power will be greater. And power is inversely proportional to time if you keep work or energy constant. So if you take less time to complete a job, you will consume more power. Well, there is another type of power related to moving objects that is known as motive power. So motive power is related to moving objects. So power is work over time, and work is force into distance. And one more thing we can do over here is distance over time. Distance over time is equal to what? This distance over time is equal to velocity. So it means that the motive power associated with moving objects, the motive power is equivalent to product of force and velocity. So power is measured in watt, force is the applied force, which is Newton, v is the velocity or speed, which is measured in meter per second. Okay, now comes the electrical power. Electrical power is product of current and voltage. So I is the current, which is measured in amperes, V is the voltage, which is measured in volts. So power equals I into V. The next thing is graphical analysis. You have to do some graphical work related to work and power. So first let's do with work. Work is product of force and distance. If you plot force along y-axis and distance along x-axis, and the graph is like this, that force is continuously changing and object is covering some distance. So if you have to find work, so what you'll do is you'll find area under the graph. So area under the force distance graph gives you work done. And you know the technique, that the gradient is ratio of y to x, right? And in the similar way, the area is product of y to x. So if y-axis is force and x-axis is distance, so product of force and distance is equal to work. So that's how we can say that area under force distance graph gives you work done. I hope this is clear. And as it is a triangle, so this is half f into d equals to work done. Okay, so power is energy over time. If you plot energy along y-axis, time along x-axis, so then the gradient of energy time graph gives you power. And again, you know, gradient is y over x. So along y is energy, along x is time. So you know, energy over time equals to power. That's why this gradient of energy time graph gives you power. Time to solve some past paper questions, right? So let's do the first question. A builder lifts 30 bricks from the ground to a platform 2 meter high. Each brick has a mass of 4 kg. What is the work done against gravity by builder in lifting the bricks on the platform? So he need to shift, like if let's say this is the platform, this is the ground, and there are many bricks, like 30 bricks are there, and he need to shift it to a platform which is 2 meter high. So how much work he will do? Well, quite simple thing. You know the work in this case, as it is moving up, gaining height, so it will be equivalent to change in GPE. So work is mgh. And as there are 30 bricks, so you have to multiply that with 30 as well. So each brick is having a mass of 4 kg, G is 10, height is 2 meters, so you multiply it with 30, so you get an answer of 2400 joule, which is option D. Okay, the next thing is, to calculate the power produced by a force, the size of force must be known. What else needs to be known to calculate the power? Well, to find the power, they said force should be there, okay? So power is work done over time, and you know work done is force into distance. So it means that if they say they knew the force, so you have to use the other two things. So of course they are distance and time. So they are distance and time, so it's option A. The next question is related to work done as well. A horizontal force pulls a box along horizontal surface. The box gains 30 joule of kinetic energy and 10 joule of thermal energy is produced by friction between the box and the surface. How much work is done by the force? Well, it means that if this is the box and a force is being applied on it, so when the box is moving and moving, so two things are being produced. One, it is gaining some speed, and second, some friction is there, so some work is being done against that as well. So we say that work done by the force is equivalent to change in kinetic energy plus work done against friction, that is dissipated in the form of heat energy. So the kinetic energy gained is 30 joule and the work done against friction is 10 joule. It means the total work done by force is 40 joule, which is option B. Okay, next question. A crane is used to lift loads vertically upward. The output power of the crane to lift a car is P. So if the crane needs to lift a car, it is using power P. The crane then lifts a lorry, which is 3 times more weight than car, and through 0.25 of the distance, like if the car was moved through a distance of 1, so this was moved for 0.25, and if the car took 1 second, 1, so one time it takes 0.50 of the time. So what is the output power of the crane now? Okay, that's fine. So you know that power is work over time or force into distance over time. So three factors are there: power proportional to force, power proportional to distance, and power inversely proportional to time. So let's see what's happened to the factors. Well, the weight is 3 times more. So it means force is 3 times more. So 3 times more power will be required. Okay, the distance is 0.25. So you know 0.25 is actually 1/4 of distance. So it means that the distance is decreased by 4 times. So distance is decreased by 4 times, so power should be decreased by 4 times. And the time is 0.2, 0.5. So you know 0.5 is 1 by 2. So it means that time is decreased by 2 times. When time is decreased by 2, power will be increased by 2. So it means now the final power, how much power is required, we'll say that, look, we'll say that as force was increased 3 times, so power was increased 3 times. So okay, it means that power is increased by 3 times. Next thing is, as distance is decreased 4 times, so power decreases 4 times as well. So power decreases by 4 times, so we can write it like divided by 4. And then time decreases 2 times, so power increases 2 times. So again, power increases by 2 times. So it is actually equivalent to 6 by 4, which is equivalent to 3 by 2 of the original power as compared to the car. So it is 3 by 2p. This was a bit tricky question. You can look at this video again. Okay, let's look for some theory questions. You have to state one advantage and one disadvantage of using a wind turbine as a source of electrical energy. Wind turbine, okay. So what's the advantage of wind turbine? We have looked at in video 2. It's like the energy source is renewable. Energy is renewable. It means that it is no cost for input. No cost for input energy. What is the disadvantage? Disadvantage is it is location and weather dependent. Weather condition dependent. Okay, now this is the windmill and the wind is hitting it and with a speed of 16 meter per second. Okay, let's gather the data now.